remember, and I don't want to remember.
No.
So I have the link here. You'll see there are the principal editions, Enterprise, BI, and Standard. And if you want to download an edition to play with that's time limited, well, I have a link for you there. There's a specialized edition, Web, and I want you to be aware of a couple of other editions that might serve you. For a no-cost edition.
Oh, that would be Express.
Express edition. And you know what? It used to be that the predecessor of Express was fairly minimally capable. Express actually can do a lot.
That's
One
good.
CPU, a gig of RAM, but you can have a 10 gig database, comes with GUI tools, can have reporting services. A lot of goodness, Rich.
Okay, but do I have to go out and get a full license if I'm working on developing something and I'm not ready to roll it out or something like that? Is there an alternative I can use there?
In fact, there is. I have linked here a link to the Microsoft Store where you can get Developer Edition, $60. Okay, it's a few pennies.
$60?
Yeah, a few pennies under $60, but absolutely Enterprise Edition, feature full. One legal restriction, Rich.
What's that?
Of course, there's a legal restriction. You can only have developer connections.
So no production on that one. Very cool. Very cool. So what are these instances all about, George?
Sure. When I am installing SQL Server, I must make a decision at the wizard step that you see here in the screenshot.
Okay.
And that is, do I want to have a default instance or do I want to have a named instance? So there are two aspects here. First, naming and connecting. But the bigger picture here is that I can have more than one instance on a machine. Picture, Rich, that each one has an electric fence around the instance.
So like a boundary.
It's exactly a boundary. So I would have a different SA, a different system administrator for each instance.
Okay.
Okay. Have a different system administrator. I can have different security assignments. I can have different service level agreements, different collations. I've listed a bunch of the reasons on the slide here why I might want to have a separate instance.
So it's more about being able to control how that instance is operating without having to affect other installs that are being used for other purposes.
Precisely.
Cool.
Just a curious fact. No, this isn't important for the test, just curious. Every single edition of SQL Server supports up to 50 instances.
That's a lot. I think that's more than most people are probably going to ever put on a single machine.
Yeah, now you and I both have teenagers, so we know just because you can doesn't mean you should. There
I
you go.
like that, yeah. So one of the things that goes into instances are collations. Can you talk a little bit about that?
Sure. I had one little follow-up thing on instances, and my reigning heavyweight of those instances or those circumstances out in the world that I'm aware of, one of my customers or one of our students, 19 instances in production on one operating system.
That's pushing it.
That seems like that's pushing it to me too.
Absolutely.
Okay, collation. So let me start off with the definition.
Okay.
So a collation is a rule book of text-based sorting and comparison rules. And part of the relevance here is that I must pick a collation. Now, as we were discussing, one thing that's good, during installation, the SQL Server installation will look at the language of your underlying operating system and at least grab you by the nose and make a strong suggestion as to what you should pick.
Okay.
There are still two major decisions, as you can see from the screenshot here, whether I use a legacy SQL collation or a Windows collation. Strangely, a SQL collation is the default, but Windows collations are suggested.
So you can use the legacy or you can use the current ones defined in Windows.
Absolutely.
Good. So can you show us a little bit about that, George? Let's go over and take a look maybe.
I would. So first thing up, we know that you have to make a collation decision. And I want to come up with a corny phrase to help everybody grasp something.
Okay.
And the corny phrase is like begets like.
Okay.
So we'll find then, let me flip over to my demonstration environment.
All righty.
All right. When I install my instance,
Yeah.
I stepped in a bear trap.
Okay.
a collation was set at the instance, and I'm able to look at this both in the graphical user interface.
All right.
And also in code if I want to.
Okay.
Now, one of the impacts of this is that my tempDB database is going to have the same collation as DAD, so to say. And that is not configurable. One other curious thing, I'd like to point out some of the naming conventions just real quick. Notice that this says it has a SQL collation, that's a prefix, as opposed to a Windows collation. And without getting too gory, we see a couple of other sensitivities here. We see case insensitive, but accent sensitive.
So the CI is case insensitive, the AS means accent sensitive.
Now, do you have memorized the list of all the other sensitivities?
No.
I don't either. But
I remember the I and the S for insensitive and sensitive. That's about as far as my memory goes.
Yeah, same here. So
all right.
Let's say now I create a new database with the graphical user interface. I, of course, have to refresh. So I did not, as you see in code, specify a particular collation.
So it assigned one for you?
So guess what happened? Like begets like. It's going to have the same collation as DAD.
Alrighty.
And in fact, just so everybody gets to see this, if I wanted to see this in code, well, I have a function that I could use, point to the particular database, and use a function that will return the particular collation of the database that I am currently pointed to.
Okay.
Whoops. All right, next up, do observe that when I create a database, I can specify an override collation. Are your kids just like you?
I hope not.
No, my kids are not just like me. And refreshing my list of databases, I go to my multilingual speak DB, and now, of course, I see the specified collation.
Awesome. So you can change the collation for an individual database if you need it. Do you have finer grain control even?
In fact, I do have finer grain control. And with the code seen here, you'll observe that on a text column by column basis, I can specify the collate clause that will then dictate how text-based comparisons and sorting will work for that particular column.
Awesome.
So following a trail, we now know we have instance collation, we have database collation, and text-based collation.
Okay.
To drill down real quick, I'll go to tables. I see this particular table. I see a column. Let's pick one of these. I'll go to properties, and what do we see? Yep, we see an override collation.
Awesome.
And Rich, you know it goes deeper than that?
Sure it does, because you can actually specify it.
Down to the query level.
Awesome.
So that's what we're going to take a look at next. I'm going to create a table. And if you observe carefully, once again, I'm using per text column collations, one being case insensitive and accent sensitive, and the other being sensitive to both.
Okay, so
All
two
right.
different collations, two different columns.
That's right. So notice I'm inserting mixed case data into both of these, which I'll take care of.
All right.
And now, querying the case insensitive data column, I'm now going to query using text data that did not match what was inserted.
Capitals in one,
That's right.
lowercase in the other.
But now when I query that, I actually have a row returned because it is a case insensitive collation.
Awesome.
Let's see where this goes now when I query the case-sensitive data column with all lowercase data. You can probably figure out the end of this movie and...
yeah, nothing comes back. No matches found.
All right, drum roll, please.
Okay.
So now we see that I can actually override collation behavior on a per query basis, once again using the collate clause. So I'm querying for the presence of all lowercase data against the case-sensitive data column, but I overrode that with a case-insensitive collation.
Very cool.
Okay, there are a couple other things in here we could take a look at, but that's good for now.
All right. So overall, basically there are some things that you can choose. There are some things that you can't choose. There are other things that you can change if you choose them wrong. So
that's right.
installation's about trying to get it right the first time, but not being absolutely locked in on everything.
That's right. So
Cool.
certainly with collation, we have some liberty, after the fact.
Yep. Awesome.
That's good.
All right, so then one of the things that we need to take care of also is ensuring that we have all of the storage set up, that we've got somewhere to put our data. Can we talk a little bit more about that?
Let's do that. Good news is, more than ever before in SQL Server, you can set a lot of default locations, as you can see from the screenshot here. And that doesn't mean you can't place files in locations outside of these, but they're just that. They set default. So if I back up data, if I create a new database, I can specify a data in a log file location, things like that.
Okay.
So in this topic, we'll take a look at general file system design principles. We'll also take a look at some advanced database design and the circumstances that may encourage that, and some of the building blocks that go into that.
So what's the first thing that we really need to think about?
Principle number 1.
All right.
Spreading.
Spreading. Don't put all your apples in one basket?
Something like that. So let's take a look at a typical Windows server, SQL server. It's going to have Windows I/O activity. We'll have data file I/O activity, which is random and also involves reads and writes.
Okay.
And then finally, we have log file activity, which is sequential and write-oriented.
Okay.
One of the biggest I/O taxes is moving that I/O head. So we don't want to move the I/O head, in particular on the log file. And also on the log file, I don't want to have the overhead of RAID parity.
Okay.
So I have here in a diagram a few different file system design suggestions, starting off with a lab machine, which is fictitious. I have everything of importance on one drive letter.
Okay.
Again, just because I can.
Doesn't mean you should.
Doesn't mean I should.
Absolutely.
So then I have a progression of maybe a small, very low workload server up to something that's much more industrial strength.
So what is the most important thing you need to keep in mind when we're talking about setting up these drives? So is there something to worry about as far as keeping data and log files separate or tempdb separate, or what are the things you need to think about there?
Yeah, like we see on the slide there, you want to separate log files and data file activity. So that's clearly, especially for a heavy workload, one of the most important design considerations.
Cool.
You're still going to have to come up with RAID levels for each of the storage units that you allocate. You have a lot of choices. And some of you are hardware savvy. Others are maybe coming along learning your hardware.
Yep.
I have a link here to, well, it calls itself raid.edu. So if you want to learn the difference between RAID 10, RAID 0 plus 1, RAID 6, RAID 5, etc., etc., there's some nice little multimedia graphics. I like to give that out to my students.
Cool. What about separation of data files themselves? Anything that we need to think about there?
In fact, yes. Looking at a more advanced database design, we'll see that this will involve multiple file groups which are supported by at least one file, possibly multiple files.
Okay.
And as you can see from the diagram here, part of the point is positioning space-occupying objects over different file groups.
Okay.
So using the principle of spreading, I now can spread out the I/O and querying activity and the maintenance activity over multiple read-write heads. I have a general rule, though.
What would that be?
General rule is, for every single file that I'm going to add to a database, better be on its own drive letter.
That kind of makes sense, because otherwise, what's the sense in having multiple files?
I'm going to have the same read-write heads fighting for the same data file activity. Now, even though my diagram shows multiple log files, it's only so that you know you can. This is not a recommended procedure. It's only going to be used if the first one fills up.
Yeah, the only time I've ever really seen that used is to migrate from a transaction log from one drive to another, is really what that helps out with.
Yeah.
So
now I want to spy, before we go to the next slide, I want to spy into one particular circumstance. Notice that I could have, let's say, a table in one file group and a non-clustered index in another file group, but observe the top of the diagram where I could actually have one single table spread out over multiple file groups.
Multiple file groups?
Multiple file groups. Now, the reason that I'm going to go to this design to begin with would be twofold.
Okay.
Performance, meaning more read-write heads involved in reading and writing. That part I already brought out. But
Yep.
Maintenance, I have smaller units of maintenance that can be done over, well, smaller units.
Awesome. Awesome. So is there anything else that you would use multiple file groups for, George?
I can back up one file or one file group at a time as well.
Okay, cool.
Yeah, so let's say I had, let's say I had, a multi-terabyte database. I might want to back that up in pieces, maybe one file per day, one file group per day. I'll tell you from experience, though, if you go to that more advanced design, you better model your disaster recovery.
Oh, yeah.
You want to have a military drill where you really know how to do this.
Yep.
Just deviating from the plan here a little bit, I find that every time there's a disaster situation, there's always some X factor, something that wasn't accounted for, something that changed. And